Hey gang, Anthony Red Hat August Radzikavage here. Today we're going to be covering Week 1's challenge of OffSec's event, the Gauntlet. Alright, let's go take a look at what this is. So, if you were to sign up to OffSec's portal, this is a free event going on for 8 weeks. They have it titled Proving Grounds, The Gauntlet Echo Response. And again, it's going on 8 weeks, so October 7th to December 2nd. The drops for every single challenge are going to be Tuesdays at 8 a.m. Eastern Standard Time. I'm going to skip the tutorial because I'm sure there's a lot of material covering that. We're going to get straight into the meat of it and cover Protovault Breach. This is a thematic event, so it does have a story behind it. So, without further ado, in the storm-battered depths of a discreet mountain peak range lies Protovault, an arcane sanctuary governed by the secretive guild known as the Everbound Order. They safeguard some of the most hidden knowledge across the cyber realms. Its defenses are forged in dragonfire and sealed with runes that demand the blood, breath, and soul print of their masters. But magic can't guard everything. Whispers ripple through the cyber realm. The vault's inner sanctuary has been breached. A ransom scroll claims access to the core spell, the foundational arcane code for Protovault, and issues a chilling demand. Surrender the Archivist Varen. Varen holds command over the hidden vaults, each safeguarding knowledge not meant to be accessed, but to protect the balance of the cyber realms. If Varen isn't given over, the Protovault could unravel everything they were built to defend. Anchorhelm, an OffSec legend, has summoned you, a skilled codecaster, to stop this before it goes any further. Alright, with that out of the way, the first thing that we need to do in these challenges is to check out the instructions. The instructions here are pretty straightforward. Click on the download link here, grab the zip file, which is password protected, with blood, breath, soul, fire. Alright, so I'm going to go ahead and copy that now. We're going to need to use that in a minute. We click download, grab it, and it says, you've been tasked with tracing the origin of the breach and uncovering the vulnerability before the anonymous adversary can exploit it further, all while protecting the Order's secrets without giving in to their demand. 2 clues are in your possession: the ransom scroll, the email, the source glyphs of the core spell, the application code. Find the leak, seal the breach, keep the Order's secrets from falling into the wrong hands. Okay, so I already went ahead and downloaded the zip file. I already copied the password here, so what we got to do is just right-click, extract all. Well, here, I'll drag this over. We extract it, and since I've already done this, I didn't need to input the password, but it'll give you a window. Copy-paste that, press OK, and then we get this cool thing right here. So, in this, they said that we have the ransom scroll, which is the email. I'm not going to spend all the time reading this. However, it's pretty straightforward stuff. Give this to somebody who makes decisions. Don't contact law enforcement or security. Prepare to follow the payment instructions and await messages for next steps. Here's your database. This is our proof that we have your database and we're extorting you for it, right? So we'll get out of that. And we have this source code.zip file. All right. Since I like to work in Kali Linux for any hacking engagements or exercises like this, let's flip on over to Kali Linux and we'll just copy this into there and work from that point. All right, so here I am in my Kali Linux VM. We're looking good here. Let me go back, and all I'm going to do is grab source code .zip from my host computer, drag and drop, put it on the desktop. Now, something that I like to do, I'll make this a little bit larger here for you. Something that I like to do is I like to create a workspace directory for any engagement or exercise I'm going through. This just helps me keep things organized if I ever have to create files or pull things in, or I have exploits that I want to try on a target. It's all located in this workspace directory. You know, if this isn't your style, that's perfectly fine. You do you, I'm going to do me. Now, I have it on the desktop, so I do want to move it from the desktop into this directory. So moving from the desktop, source code .zip, and to this directory, the period, right? And I did LA, which was fine, but we can list that and we see the file is indeed in place. Okay, give me just a moment here. All right, perfect. Okay, with it here, let me clear. We will unzip it into this directory just by executing the unzip command and the zip file. And we can see that it is extracting all of the contents. We have this .git directory with a bunch of stuff in it, and we have the requirements and the app directory. Looking at this a little bit different, if we do an ls-al, right, listing all the files, hidden directories, hidden files, and in long listing format, we see the same exact thing, albeit maybe a little cleaner, being as how the zip or unzipping showed every single thing that was in here. Now, let's go back before we continue. Let's look at our first question that we have. All right, so we left off at the lab instructions. We're going to go ahead and click back on the play tab. And let me try my best to just inch this down. Give me a second. There it is. So our first question is to determine if the leak could have come from the application. We'll review the database connection string to ensure it is secure. Submit the connection string here. Okay, so this is specifically asking from the application. All right, now let's go back to our Kali machine. All right, so here we are again, back at our unzipped file location. Since we're looking at the application, let's go ahead and go into the app directory. All right, we'll do a long listing here, and we see that we have app.py, forms.py, init.py, which is empty, templates, and util. Just for the sake of coverage, let's do a long listing on templates and a long listing on util. And the util directory is empty. In the templates directory, we have these web pages, so we have HTML files here for that. And, you know, we can look at those later on. However, let's look at the actual application files, and we're going to start with forms.py. All right, so I'm going to type view forms.py, and what this is it's just like Vim, but it's in read-only mode. This gives us the nice pretty colors here, so I'll continue to use view instead of cat just to get the pretty colors. To get out of it, it's just like Vim, do a :Q, and then you escape out of it, right? But here we have a Flask form, and it's for the login form, item form, and note form. And no, there is nothing of interest, nothing sensitive in this file that would give indication of any type of vulnerability. So let's get out of that, and we'll go into app.py. And boom, look at this. We have a secret key, boom, right there. That's not great, right? So maybe I'm going to store this. I'm going to try to keep these in mind as I progress forward. And there is the database URI, aka the database connection string right here. Now, to do our due diligence, let's go ahead and go down and see if there's anything else that jumps out at us in this Flask application. Nope. That really was it there at the top. So let's get out of this. And what we'll do is we'll just go ahead and grab the PostgreSQL on the app.py. We can grab this and copy it. And then let's flip back over to our questions here. All right, now that we're back here, we'll scroll just a little bit further down, paste our database connection string, and boom, we got question 1 out of the way. All right, now let's proceed to question 2. Review the other source files. Which one may have leaked the database? Provide the file name. Okay, let's get back into Kali. All right, here we are. Let me clear this out. Now it did say the other files, right? So that wouldn't be app, and we've already covered forms.py. Okay, so the only ones left here are the templates files, right? So we'll go to templates, base HTML. We'll kind of scan this and see if there's anything that might give indication of a leak or sensitive data that could be scraped out of this. Nothing in that one. Let's do templates category. And I'm going up because I was at the bottom of it. So nope, nothing in that one. Do the same thing, but this time for index. And nope, nothing here. I think there's item detail. Let's see. Nope, nothing here either. Okay. And the last one, login.html. And also no, there's nothing indicating any type of leak or sensitive information outside of what's in app.py for that secret key and, of course, the database connection string. But for that database connection string, right, what we're looking for now is, in terms of the leak, is like something publicly available, something that we can get from the outside of the corporation into their database or get their database, right? So that's not quite it either. With that, let's go back a directory. So we're now where we unzipped all of the files, and we'll do a long listing here. Okay, so here we already looked at everything in app, but we have this .git directory, which means that this is a Git repository. And when you're working with Git, right, you're developing your code, you're making changes, you're uploading, you're pushing your commits, right? Hint, hint. There's a whole history, and it's just not one time that you write all of your code and then you're done. So since we see that this is a Git repository, we should check that commit history. Easy way to do that is to do cat.git logs on the head file. And these are all of the commits that were made for this repository. We see the initial commit is right here. And then they had a UI refactor, adding authentication. They had some database migration scripts. That's interesting. Data models, right? So we have all of these comments for these commits. And then the original commit from where it came. So it's all zeros for the first commit because the first commit identifier here, the commit string, is this. But you'll notice on the UI refactor, this commit was where it came from, and then this is the actual commit for this new code, right? When they pushed up this code, it's under this commit. Now, before we get too much further, I want to cover git log as well, because Git has the commands to look at these. So we do git log, and you'll notice that this is the release candidate. We can see the date that it was released. We can see what the commit is. We don't necessarily get the benefit of the head file like what I just showed you as far as seeing the commit before and the commit, that is this one. We only see this commit, but we do get the information out of git log as well. So another difference is the head file will start with the very first commit and then go to the latest one. You'll notice that this starts with the latest one once I get there, from the latest one, and works down to the very first one that was committed. So they are in reverse order. All right, now we see these things that are in here, but I want to take an opportunity to teach you a tool called Git Secrets, right? We can use this tool to look up patterns or search strings in a Git repository to see if we can find any sensitive information, as opposed to looking at every single file manually. To get started with that, let me clear that out. We need to install it, right? So sudo apt install git-secrets. We authenticate, and there it is. Okay, so to get started with this tool, we're going to need to install it at the root level of the Git repository in your local machine. Okay, I know that's a little verbose, but the bottom line is if you install it, make sure you're in the directory that has the .git directory. Okay, it's like you're attaching it to this, so you need to be on the right place. You can't just be anywhere on your system. Be where the Git repository is. If you're there and you're ready to go, then we can enter git secrets --install and check it out. It is installed. It is rocking and rolling. Now, if we are looking for API keys or any other types of secrets, maybe we want to scan for, a hosting service such as AWS, right? If they're doing cloud computing in AWS, maybe we want to scan the repository for any interesting bits that might be related. We don't have to manually put all of those in. Instead, we can just do git secrets --register -AWS, and it says, okay. So now it's registered with some AWS, patterns and strings, and we can scan this to see if anything of interest to us as hackers is inside of here. However, I'm going to add a couple more manually just to get some more coverage. So I'll do git secrets --add, and I can add my own string like password equals. And I'm going to add another one here because I saw it, which is secret key. So we did see that in the app.py file. Okay, with those added and registered to AWS, we can work with this in a couple of different ways. I'm going to start with just scanning what we have here, and it's git secrets, --scan. And you'll notice, oh, hey, there's a prohibited pattern here, secret key. It's in the app.py file on line 8, right? And then this is the file, or the line contents that contain that. It didn't find anything else within, our current space, if you will, right? The way that the directory is set up, the Git repository. But keep this in mind if you are a developer and you're using Git. Maybe it's a good idea for you to install Git secrets and run this before you push your commit, right? You don't want these things escaping you. Now, another thing that we can do, and this is super cool, is instead of just scanning where we're at, we can scan the entire history of a Git repository. So we just do --scan history as our option, and look at this. We have the secret key string here, right? The pattern that is prohibited. But there's something interesting, at least in my opinion, about this. And that is, each one of these in the beginning, right, the first column here before the colon delimiter is a commit. So we see that these are different. However, we see that the secret key is this really long string, and that's pretty great, you know, in terms of comparative to super secret key, not so great as compared to change me, even worse, right? But it goes back to that string, and then it's the same three, right? It's the same three. So what I want to do is I'm going to kind of keep this in mind, and I'll store these to the side in case they become useful later. Maybe super secret key is going to be a reused password, and same thing with change me. Maybe it's not just for this application, but if I look at the developer and, you know, maybe some of their other work, I could cycle through this and it's like, oh yeah, this is the super secret, super secure one. But if they reuse it somewhere else, then I can abuse that password reuse vulnerability and gain access to other areas or other applications or potentially even other databases related to that developer's work, right? So seeing patterns like this, I think, is advantageous. All right, so that's what I had for get secrets. However, let's go back to the manual git log commit, review here. We're going to instead look for something different, because what is a commit? A commit is where you're developing your code and then you push it with a commit, or you don't push it, excuse me, you stage it with a commit before your push, and then you're going to push it to the repository. It's going to update that repository file contents with the changes that you've made. So as we're developing those applications, we're writing the code, we say, oh yeah, I updated this, and then, I'm going to do a git commit, stage all of that, and then when I git push, boom, it goes up to whichever branch I am working on. So again, if we look at cat git logs .head right here, there was something else that I thought, oh, this is interesting, and that is remove backup scripts. Well, yeah, when you're developing code, you're going to be adding stuff, but you might also remove stuff, and that's really where the juicy bits come in, right? Oops, I accidentally uploaded, all the usernames and passwords to my Git repo. Not great. I accidentally uploaded my SSH key to my Git repo. Not great. So we can actually use git logs and filter out files that have been deleted, right? So let's do that right now. I'm going to clear that out. We'll do git logs, and we're going to add the option of diff filter equals D for deleted, and let's just get a summary version of that. Oh, hold on, not git logs, git log. And look, instead of having everything here, it only shows where the files were deleted. And notice we have app util backupdb.py and restoredb.py, which we didn't see when we were manually investigating with ls through our current state in the repository. Makes sense because they removed them. Okay, so in this, it's like, this is interesting. What can we do here in terms of this information? Maybe this is the source of our database leak. It's backing up the database. All right. Well, remember before when I was talking about that head file and it being able to show us the before and the after, right? So the before the commit and then the commit itself. Well, this is the commit that was done to remove those backup scripts. Yeah? So if we go here, these files aren't going to be here. We want to go to the commit right before it. So let's go ahead and we'll just go ahead and cat that head file again. And you'll notice, fortunately, the developer gave us a big, they did us a big favor here, and they said remove backup scripts, remove backup scripts, and remove backup scripts right there. So if I were to filter that out by piping that output to grep, and then I just put remove, just for the sake of, I'll go ahead and put that in quotes. These are the 3 commits where they removed these backup scripts 3 separate times. So remember, let's just go ahead and do it. I'm going to go to this commit where they removed the backup scripts. The way I can do that, I can do this in 2 different ways. I can do it with get checkout and then the commit string right here, right? Or I can do get branch -c and the commit string right here. So I'll do it this way just to show you. So I go ahead and I do this, and if I ls-al, you'll notice that I have the app directory, the .git directory, requirements, all this looks the same. If I go into app, right, let me clear that first. And I long list, you see that I still have the same files, and if I do templates, the same files, and if I do util, the same files. And it's like, oh, hey, but the commit, I was expecting to see those. Again, remember, the commit was when they removed it. We need to go before that commit. So let's go ahead and do get checkout main. That'll get us to the latest and greatest, the newest one. And let's do, oh, let's go back. There we go. Let's go to the one before, right? The commit before the one where they removed it. So that's going to be here. And you saw me use get checkout. I was already on main, right? But this time I'll do get checkout on the commit string. And I'll say, hey, give you a detached head state. You can look around, make experimental changes, but like if you want to do something with this, maybe consider switching to a new branch, or, if notice when we did the branch -c, it would change the branch and we were in that commit level. So we have the files here, right? Sorry. But you'll notice the requirements.txt is gone. Oh, interesting. Things are different. Things changed, right? So let's go into the application directory. We look at that, and remember, this is in util. And there they are. So if we view util backup db.py, boom, look at that. We have multiple issues here. We have an SSH host, right? This is a local machine, most likely on their own domain. So, maybe we can get access to it, but we know that SSH on port 22 with the username of dbadmin and the SSH key of PGSQL key on Walter's computer, right? We could gain access to this. So for me, I'm making personal notes like, this is of interest. If I get into their network, if I can get onto this machine, I'm going to want to grab this key, and then I'm going to use the username dbadmin on this host to gain SSH access to it, right? So if I can grab this key through whatever means, this might be an entry further into the network or even to more databases since, it's a database admin. Now, we also have the database name, database user, backup file name, right? So let's keep going down. Oh, and here, there we go. I went a little too far. We have an S3 bucket. That's interesting, right? We're going to be backing this up to an S3 bucket. And if we continue to go down and analyze this, it says, okay, do the SSH client, sure. You run the backup, it dumps it, does the thing. It removes it. Oh, there's an encoding function here, and woo, super secure. It's ROT13, and by super secure, I mean this is terrible. It's awful. It just shifted the alphabet 13 characters over. This is not security at all. So that's something to pay attention to as well. Now, here is what I was interested in. It's the upload to S3. So S3 colon / S3 bucket, S3 key. We just take the variables that we saw above, PGA management backups and latest backup.xyz, and pop it into this address. And this would be our S3 bucket address to get that leaked database. And that's it. This is the whole backup script that they have. So we might be able to answer question 4, since we already answered question 2 with app util backup db. This is the source of the leak, right? So let's go ahead and get back into the questions here so that we can make sure that we're addressing what we need on that front. Okay, now you might have noticed that I went from question 2 and I jumped to question 4. I'm going to explain that here in a moment. But question 2, as we identified, hey, there's the S3 bucket, there's the database. The file responsible for the leak is app util backup db. Now you're going to see the answer to question 3, but we're going to work through the process. So submit the public address of the database leak, including the name of the file. All right. With that, we'll go back into Kali Linux, and we're going to work through the process of figuring out this tricky answer. Okay, so what we had before is if I do a grep-i to ignore the case on S3, and I do this on util backup db, I get this information, right? So I have the S3 bucket, I have the S3 key, and then I have the address here ready to go. Now, that would make the address something akin to S3 colon / PGAMGT -backups, and then / we populate the S3 key. Latest, not latest. There we go. Latest. Oh my gosh. There we go. Backup.xyz. So this would be the S3 bucket address, doing it through the command line like what they did. Now, of course, that's not a command. I'm just putting that in there for your benefit. Now, if I wanted to, what I'll do is I'm going to go back a directory into the root here of where I unzipped all the stuff. Okay. And I'm going to use AWS CLI to download the contents from that S3 bucket. In order to do that, guess what? We have to install another package. So sudo apt install AWS CLI. And we authenticate. And this time we have to push Y for yes. We press enter. And with this, we're rocking and rolling. Okay, so for this, we're using AWS CLI, right? The command line interface. So AWS is the command utility, and we are going to be working with an S3 bucket. What do we want to do with that? We want to copy, again, the, you know what? Let me do this. We'll go up, Control-C that, and then let's go AWS S3, copy this bucket and file, right? And I am going to put it in the directory I'm in right now. When I press enter, you'll notice that it says, hey, fatal error, unable to locate credentials. And to save us all a bunch of sanity, because I'm sure this video is pretty lengthy, there's no credentials that are leaked in any of these files and, you know, in the Git repository that we could find. Now, instead of digging through all of that, what might be something that we might want to try? No credentials, right? So we are going to add no sign request like this at the end to skip credentials and, just try to download the file as any Joe Schmo would. Now with this, we get a different error, which is a 404. Hey, this doesn't exist. It's not here. So, it's like, but I see it in the file, and the file's responsible for the leak, so what gives? Well, remember, secret key was changed, right? Code changes, it evolves, and maybe, just maybe, this isn't the location where it's at anymore. Or, maybe this one was secured at one point. So we should probably be looking through our other commits related to this specific file that, its presence there and its contents may be different than what we see now. So let's go ahead and go get checkout. Main again. There you go. So we're back to main. And let's see. I wanted to do the cat.getLogs head grep remove. And remember, we just went from the top, right? And we want to go to the commit before. So let's just move one down. We'll just manually do this. And we'll do get checkout into this commit. We'll clear that out. And if I do a view on app util backupdb.py, go to the top, and we see the same information for SSH. We see the same information for DB, but oh, hey, look at that. This is different, and it gives us an S3 region. So it tells us what region in AWS this S3 bucket is stored. So with this, let's get out of here. And we are going to grep dash, or actually, let's just do it grep capital S3 to app util backupdb.py. And we're going to piece this together with that AWS CLI command. So we can do AWS S3 copy. And this time we're going to use our bucket name as this. ProtoGuard asset management / what is the key or the file? It is dbbackup.xyz. We're going to copy it into this directory. And we are going to specify the region is US East 2. And again, we don't want to supply credentials. We didn't find any credentials. Just open download. We press enter. And look, no 404, no credential errors. Instead, we now have dbbackup.xyz. Now, you may want to know that there are two other ways to download this. Let me go ahead and grab those real quick. I got to find out where that's at. Okay, let me grab this right here. So if I go to a web browser, and I wasn't going to use the AWS CLI utility, right? And I went to https://s3.us-east2.amazonaws.com ProtoGuard asset management db backup xyz, right? So I'm supplying the, let's see, subdomain of S3. I'm supplying the region, and then it's in Amazon AWS. The bucket name is right after the .com, right? And then the file name is at the end. If I press enter, you'll notice that I have db backup xyz downloaded. So that's another way you could download it. Here's another variation of doing the same exact thing, which is to use the bucket name as the subdomain, and then S3 US East 2.amazon.aws.com, and then supply the file name in this way. And guess what? You'll notice that that also downloads the file. For whatever reason, and this could just be one of those things where, oh yeah, there's a million ways to skin a cat, and I don't know why you want to skin a cat, but boy, there's a lot of ways to do it. Only this and the AWS utility address, how would I say, formats, right, or schemas will work as answers. So the first HTTPS protocol schema that I showed you that does work just isn't accepted as an answer. So do one of the other two. All right, since that's out of the way, let's go back to the questions. All right, and we already got the database file, so we submit the public address of the database leak. And since I was using AWS CLI per the code that I was reviewing in the Python script, I put the S3 address right here. All right, now using the results of your analysis, discover the public address of the database leak. Yup. Verify the contents of the leak by submitting the password hash for Naomi Adler. All right, you see it here, but how did I get to that? Let's go back to Kali. Okay, so we already downloaded the database from the public S3 bucket that was available. And if I simply, let's do a cat, because I don't want to like have a bunch of stuff here. You'll just kind of see the gist of what's going on. If I read it, whoa, what's this? Oh, this looks very odd. This is not human readable. Oh my gosh. Okay. Remember before when we were analyzing the backup script? Let's go take a look at that again. Let's do view app-util backup DB. Let's go down. Remember this? Right. Oh, whoa. Hey, what's going on with you? There we go. You remember this? Right here? Yeah. It's encoded with ROT13. The alphabet's shifted 13 characters over. Now I could grab the contents of this, throw it in an online, Caesar cipher, shifter, decoder, whatever you want to call it. Or we can use the command line. Notice I like the command line. We can use the command line to do this ROT13 operation for us on this file. So let's break that down just a little bit. Again, we have catdb backup. It looks like this in the way that we got it. So we're going to use a utility called translate, right? That's just TR. And our goal here is to take the capital letters A through capital Z and the lowercase letters A through lowercase z and translate those into a shifted range. So we're taking the characters, single character here, and we're going to translate them into the range here. Well, capital A is going to become N, so A through, what would it be? M would be N through Z, or maybe that's L. But either way, shifted over 13 characters. However, the capital A through capital M would be the latter half of that shift. And then we want to do the same thing with lowercase. So N through Z and A through M. All right, so that's the translation. Now, what in the world are we translating? We're translating the file. So in the translate utility, we're going to supply an input redirector, meaning take the contents of database backup.xyz and translate it according to what we specified here. All right. If I press enter, you'll notice that this is now in English, right? We can read this. This is great. However, if I list the directory contents, I didn't save it anywhere, so I'd either have to type it or I'd have to find it in history if I wanted to do this again. Remember, I have this workspace directory in case I create any files. Let's do it now. So we're going to take the output of that and do an output redirector to create a file called decoded backup.sql. And we're just going to put .sql to let us know that it's an SQL database, and that's what we're looking at. So now if I do cat decoded backup.sql, it's here, and I don't have to do that translate again, right? Like, we are good to go. So in this, there's a couple ways that we could do it. We could just view it, right? As we did before. And honestly, when I was going through this challenge, this is what I did. And then you scroll and you scroll and you scroll and you scroll. And you're like, oh, okay, where's Naomi? All right. Oh my word. I'm going to keep going. Hey, here's users. And we can find Naomi Adler right here. Or another thing that we could have done is just filter out Naomi or Adler, something that seems sensible for us to look for that specific user and just get that line out of the file, right? So let's do grep-i and then Naomi on decoded backup.sql, and you'll notice that it pulled out that line out of the file, without me having to scan through all of it and look around. I also want to stress that I did an ignore case on Naomi because who knows if what the capitalization is going to be, in the name of the username or even the name as they register. This is all over the place. So just ignore the case and you'll have much better results when you're scanning through stuff. But either way, question 3 is asking for the hash of Naomi Adler to show as proof that you were able to analyze the leaked database contents and get to this point. All right, so we just grab that and let's go shift back over to the answers or the questions. And we just pop it right here in question 3's answer box. And you did a great job. So this completes week 1 of OffSec's event, the Gauntlet Protovault Breach. So thank you so much for joining me today as I walked through week 1's challenge here. And if you liked what you saw, if it was helpful to you in any way, if you learned something new, please feel free to drop a like, share it, subscribe, and leave a comment letting me know your thoughts. I'd be very grateful to hear it. All right, with that, I'm Anthony Red Hat August Radzakavage. Happy hacking.